All right. So today we're expanding what we've been doing the last couple days. So again, if you don't get everything, that's okay. We start in 7th grade, you learn a little more in 8th grade, by 9th grade you're pros. So, but you can get enough to answer the questions and to figure things out. So don't just give up when you go to do your practice after these notes. Don't give up. You know enough to choose the right answer. Do what you know, and then you can pretty much decide on an answer by just the basics that you did. Um, so our notes say a department store currently has 30 employees. It plans on increasing its workforce by 5 employees each month until it has tripled its workforce. So we have a store. A department store is like Macy's or Dillard's or JCPenney, where it has a bunch of different kinds of things in it. It has 30 employees and it wants to increase its workforce. So if we're increasing, we are getting more employees. And they want to do it 5 people each month. Now it says that they're going to stop when they have tripled. If they started at 30 and they need to triple means times 3. So how many employees do they want? They're going to keep adding until they get to 90 employees, because 90 is triple what 30 is. So that could take you a long time of just adding 5. So first month, 0 month, they start with what? 30. And then they add how many in the first month? They add 5. So now how many employees are there? Altogether, 35. Now month 2 comes around and they add 5 more. Now how many employees do we have? 40. Now month 3 we add 5 more. How many do we have? Month 4 we add 5 more. How many do we have? Hit pause and finish filling that in. If you didn't hit pause, you need to hit pause, push pause, and finish filling in your table. Now, we're still not to 90. In fact, we're a long ways from 90. And the truth is, I'm tired already. I don't want to make a table until I get to 90. So the equation is what we use to shortcut. What am I adding on each month? I'm adding on 5 each month, right? So that's 5 times the number of months. And I know months is M. I'm still going to put X because that's what we use in our equation. But we didn't start at 5. We started at 30. So whatever I add on is going to be added to the 30 I began. So when you find your equation, ooh, I don't have a green. When you find your equation is always written y equals mx plus b. And we said to find mx from a table, we're going to find the change, right? So really, how much are we changing each month? On the x side, we're going up by 1, and on the y side, we're going up by 5. y divided by x is 5. So mx is 5x. And b, well, that's where I started. Wherever I start is b. So that's 30. So this y equals 5x plus 30, that is our equation. That goes down here. It's not on my screen. You can't see it. We can use that to anticipate a gazillion numbers so that we don't have to make a table forever and ever and ever. If I want 300 employees, I certainly don't want to make a table until I get to 300. I'm too lazy to go to 90. That's the truth. All right, we're going to plot some points. All we're doing is taking these numbers and putting them on the graph. So our table is x and y, and our graph has an x and a y also. So for 0, 30, start at 0, and I'm going to go sideways 0. And then I'm going to go up 30. Do you see that this and this and this, these are all the y-intercepts, right? That we started on Monday, and I said it was the most important thing you had to learn that day. Because it's where you start. Now careful, if you look here at the bottom, are we going up by ones? Going up by twos. So we're not even going to graph when x equals 1. What happens when x equals 2? We have 240. So on my graph, I'm going to start at 0. I'm going to go sideways 2 and up 40 and put a dot. And then my next one's 4, so I'm going to skip 3. And I have 450. So starting at 0, I go sideways 4 and up 50. And then I'm going to do that for 6. On my table, I have 6, 60. Do I have a straight line? Yeah, pretty much. I can't draw a straight line, but it should be pretty close to straight. If you have a curvy line or a U-shaped line, in 7th grade you did something wrong. We saved that crazy stuff for 8th grade. All right, you've already written your equation. You filled in your table, you have a graph. The question says, what is the solution? Now, if you look up here, it says they want to triple their workforce. They want to get to 90 people. But we don't want to make a table till we get to 90. So we need to figure out what it's going to take to equal 90. And I like to do it, we already have the equation y equals 5x plus 30. You've already got that in this box. Let's replace y with 90 because that's what we want. Now you're going to solve it like a regular 7th grade equation, which actually we haven't done yet. So your first step is to subtract 30. These cancel out and you're left with 5x. On this side, 90 minus 30 is 60. And you know how to solve an equation that looks like this. You're going to divide both sides by 5. So in a complete sentence, let me reread the question. The question says, it plans on increasing its workforce by 5 employees each month until it has tripled its workforce. Complete the table in the graph, then determine the equation that can be used to represent the situation and the number of months it will take until the department store reaches its goal. Its goal was 90. So, in a complete sentence, it will take the store, how many months did we say? 12 months to triple its workforce, or triple its number of employees if you don't like the word workforce. But it's going to take 12 months. Glad we didn't have to make a table all the way to 12. All right, flip your paper over. We have a graph at the top of your paper. And I know when it's small, it's kind of hard to see, but it's not impossible. And it's on your computer right now, so you can always enlarge it. So on a graph, you're going to label Y and X. I know it's already labeled. Label it again. And then I want you to go ahead and label your quadrants. This is quadrant 1. And we do it backwards. I don't know why. So this is quadrant 2. Quadrant 3. You need to use the Roman numerals, not regular numbers. And quadrant 4. And we have this beautiful line cutting through our graph. And you need to find the y-intercept and highlight it. With yellow, with a marker, highlight the y-intercept. This is the y. Where does that line cross the y? Right there. So our y-intercept is right here. What number is that? It's 2. So it says name the ordered pair where the line crosses the y-axis. So ordered pair, that's this, where it's x, comma, y. Where it crosses the y-axis, what is the x for that spot? Did you go sideways? Not at all. So your x is 0. And your y, we said was 2. Now, what is that point called? It is in your notebook from Monday. It's what we highlight over and over again. It is the y-intercept. Now, B says, name an ordered pair that is on the line and is located in quadrant 3. So it could be any of these spots. Make sure whatever you name, it's where you can easily read the numbers. Like this here floating in the middle of nothing, not a good spot. Find where it's touching a nice corner and you can read all the numbers. This dot here is x comes first. So how far sideways did I go? -5. And how far up and down did I go? -3. So one of the ordered pairs in quadrant 3 is -5, -3. I think you need to list one more. The key is, if it's in quadrant 3, everything's negative. Now question C says to create a table of ordered pairs that are on the line. So I'm not going to scroll down because then I can't see my graph. I'm just going to make a new table. You already have 2 ordered pairs. Why don't you use what you've already written down? And you wrote down a third already. And just in case you didn't, if I come and draw this dot, my x is 6 and my y is 8. So now you have 4. You only have 3 spaces and you already have 4 ordered pairs. Here's where you get to answer D. And D is what we've been practicing. But remember, when you're answering your questions in a little bit, if you can't do the whole thing from scratch in your head, it's okay. You know enough to solve the puzzle of the problem. You know enough to figure out the answer. D says to write the equation, and it tells you it's going to be y equals mx plus b. Now when we see B, we highlight it because B is the y-intercept. What is our y-intercept? Plus 2. A ton of our problems. If you can find the y-intercept, you have the answer. And check it out, your y-intercept is here too. So all of this 2, this 2, and this 2, they all come from the same spot. Now you still have y equals, that doesn't change. Your mx, that's the green part. You can do it with a triangle. Do you remember how we did the triangles? You can do it with a triangle, or you can do it with bunny hops. Your choice. I'm going to do it with the triangle first and then with the bunny hops. You're going to see they're the same. So my triangle started at the left. This is my second point I made. Started at the left point, went sideways 4, and then I went up 1, 2, 3, 4, 4. So if it's going to be k equals y over x, y is vertical, that number is 4. X is horizontal, that number is 4. What is 4 divided by 4? 1. So let's do the bunny hops and see what we get. Going from 0 to -5, am I going up or down? Down. How many? 5. Going from +2 to -3, am I going up or down? Down. How many? I'm at +2. I'm going to go to -3. 1, 2, -1, -2, -3. How many times is that? 5. So this time, y is what number? -5. And x is what number? -5. And any number divided by itself is 1. So y equals 1x plus 2. And in real life, we usually don't write the 1, so it might be y equals x plus 2. So if you don't see a number, know that it's 1. Either way, triangle, bunny hops, doesn't matter. Whatever you like.